This is a video on the general notes or information about kinetics. By this time, you should have received this and have read it. So when we have a chemical reaction, usually there's several questions that are asked. The first one is, does this reaction occur or not? And then another question is, well, if it does occur, how fast can you make the products? In essence, how fast does it react? And then the third thing is, well, how does it actually come together? In essence, how do the reactants actually become products? So, for the first question, does a reaction occur or not? That's thermodynamics, and it has to do with energy, and specifically has to do with Gibbs free energy, and that's a different video or YouTube video when we talk about that. The other two, how fast can you make products and how are they actually put together, that is what kinetics answers. Kinetics does not care about does a reaction occur or not. It has already assumed that. What it does care about is the time it takes to make the products and how they're made. The most common model used for kinetics is called the collision theory. And to me, it's just an extension of the kinetic molecular theory. If you remember, the kinetic molecular theory says that all substances are made up of particles that are in constant motion, and sometimes they interact. Well, that interaction is actually collisions. So that's what this is. When the particles collide, what happens? Well, if it's a chemical reaction, they collide and they reorient themselves and they fall apart as reoriented differently. So that's what collision theory is saying. To actually do kinetics is an experimental concept. You have to do the experiments to actually come up with true kinetic information. What we're going to be teaching you is more of the theory or simple kinetics that don't require you to do too much experiments. It's not the fact that the experiments are hard or the mathematics behind it are hard. It's just it takes time. We don't have the time. Usually in first year high school chemistry. AP, we spend some more time, and then most likely in college you can spend even more time. So, so what's the big thing about the collision theory? Well, to make the collision, to make a product, the reactants must what they call effectively collide, or you must make an effective collision. That's what causes a set of reactants to form a set of products. So not all collisions are effective. So therefore, not all collisions will make products. What happens is they collide and they basically bounce off each other and stay the way they are. The other thing is that in general, only two reactants can collide together. Okay, so to be more technical, to form this effective collision, you need two things. You need the right amount of energy, or at least the minimum amount of energy, which is called the activation energy, and the particles must have the right orientation. And orientation means, to me, two things. One, they must be close enough together to collide. That's part of the orientation. And the second thing is they have to three-dimensionally be in the right collision. So you can't like hug. You don't usually hug people from behind. You usually hug two people facing each other hugging. So that's the orientation. Okay. So that's one of the defining things is that for an effective collision you have to have both each particle must have a specific amount of energy called the activation energy, and they must be near each other and in the right three-dimensional orientation. Now, once you have that, the rest of kinetics is basically broken up into two parts. The first, which is called the rate of reaction, talks about how fast you can make the products from the reactants. And the second thing is, so the rate of reaction here, and the second thing is what they call reaction mechanism. That explains about how you put the reactants together to form the products. Okay, the first one, how fast the reaction goes. For first-year people, we only do the factors that change the rate of reaction. So we're going to explain different things different conditions that will increase or decrease the rate of reaction. This whole rate law thing, that's more for AP or people who are going to get into more depth with the kinetics. Okay, so if this is the first year, we won't talk too much about rate laws. We'll just talk about the second one. The reaction mechanisms. So again, these are overarching things. The reaction mechanism. The big thing you need to know about that, and again, we're not going to go in, if it's level 1, we're not going to go into too much detail on this. But the general information you need to know about reaction mechanism is that only two things smack together effectively. Maybe on the outside, 3 things. But when you try to get more than those many things colliding with the right amount of energy in the right orientation, it becomes statistically irrelevant because you don't get that many effective collisions. So therefore, what you find out is that a lot of times what you think is happening, that the reactants are smacking together, all of them are smacking together, and then you make the compound, make the new products. That's not actually what happens. What actually happens is 2 things smack together, form something else, intermediate, and that intermediate stays together. And that intermediate, which is one thing now, smacks up with another thing, and that may be another intermediate, or that may be one of the products you get. So what you actually get is, even though you have one chemical reaction, you actually may have multiple what they call reaction steps. And each reaction step is only 2 things smacking together, and some of those things aren't even in the overall chemical reaction because they're basically called intermediates. They're subsets that don't actually survive through all the different reaction steps that you do. The other thing you need to know about the reaction mechanism is these subsets, the overall reactions rate of reaction, the speed of the overall reaction is determined by the slowest substep or reaction step. It's called the rate determining step. And again, that you have to experimentally determine that. But you have to increase the rate determining step, which is the slowest step, so that the overall chemical reaction rate is going to increase, i.e. making more products. Okay? So that's what you need to know about reaction mechanism. So, going back to the basics of collision theory, um, the rate of reaction, that's the name we give how fast you can make products. Okay, the units are usually um, some type of measurable unit per time, and it's for kinetics. It's always about the reactance. Okay, you do talk about rates of products, but they're always with respect to the reactance. Okay, and what we have here, this graph, this is called a potential energy diagram. It's used not only for thermodynamics, it's used to explain effective collision. Um, so what we have here is we have the reactants. They bring a certain amount of potential energy in the reactants. And what has to happen is that energy has to be added to, which is the activation energy. So the activation energy is in addition to the energy of the reactant. And if you do get enough activation, or you get enough energy to get an activation energy, then what happens is the two particles will collide, and what will happen is they will collide together, and they all come together, and that is what is called the activated complex. And the energy in that activated complex is both the energy of the reactants and the activation energy. So it's the whole thing. And it only lasts for a billionth of a second. And what happens is it falls apart into products. In this case, it falls into products, and the product's potential energy is this amount. That's considered an effective collision. Again, this is the activation energy. And that's the only thing that we can change. In this whole diagram, that's the only thing we can change. Everything else is set by thermodynamics in what the reactants and products are. So kinetics can only change the activation energy. This happens to be an exothermic reaction. You've known this from other videos. The potential energy of the reactant is greater than the potential energy of the product, and this is the heat of reaction and the amount of energy that's being released. So this diagram shows you one of the two factors of an effective collision, which is you need a minimum amount of energy called the activation energy to create the activated complex. The other thing is they only smack together to make an effective collision if you have the right orientation. Again, two parts. One, they have to be near each other, and two, they have to be three-dimensionally in the right orientation so that they can collide correctly. Here we have another diagram, which is called kinetic energy diagram. This is actually a profile of what temperature is. This is the y-axis is the number of molecules, and the x-axis is energy. Since temperature is defined as the average kinetic energy, then all the particles don't have the same amount of energy. That's how you can see here. The height of the graph or the curve is the number of particles with that amount of energy. So what this shows you is not all the particles have the same amount of energy. Why is that important? Well, from above, we know that any particle that has the activation energy or greater has the potential of making an effective collision, i.e. make a product, but the ones that are less don't. So if the activation energy is, let's say, here, only the particles that are over here that have more energy have the potential to make an effective collision, i.e. to make products. All these guys over here, even if they collide in the right three-dimensional orientation, they can't because they don't have the right amount of energy. So only these particles can make an effective collision. Okay? So far we have highlighted a few things. One, that kinetics, which is a completely experimental concept, tells us about how fast we can make products, the rate of reaction, and the mechanism by which reactants become products. Does a reaction occur or not? That's the realm of thermodynamics. Okay, kinetics only cares about time. Thermodynamics actually don't care about time. They just care if it actually happens or not. The other thing is the whole theory of kinetics is based on the collision theory, which basically says that to make products, reactants must have an effective collision, and to have an effective collision, you must have particles with the right amount of energy, called the activation energy, and they must be in the near each other so they can collide, and two in the right orientation when they collide. And if that happens, you have an effective collision. You create what is called an activated complex, which breaks up instantly into the products. In general, only two things can collide and make an effective collision. On the outside, maybe three. But statistically, anything more in the reaction can't happen fast enough. That lends us to the two major concepts of kinetics: how fast a reaction goes, called the rate of reaction, and how the reaction is actually made, which is called the reaction mechanism. When you do a lot of math, you look at the rate law. First year people, we only look at the factors that affect or increase the rate of reaction, which will be another video. So if you're doing AP, you're going to be talking about rate laws from on another video. Which, with the reaction mechanism, how the reactants actually come together, only two things will collide. Therefore, if your overall chemical reaction has more than two things, that is not how they're going to collide together. So what you have is you have subsets, which they call reaction steps or mechanism steps. And what happens there is only two things collide and you form products. Sometimes those products are actually consumed in another step and they don't make it in the chemical reaction, overall chemical reaction, which is they're called intermediates, and sometimes they do. No matter, there will be one step that's the slowest step, and that's called the rate determining step, and that's the step that determines the rate of the overall reaction. In that you'll have to be responsible for two tables: the potential energy table and the kinetic energy table. Anything else we'll do on a different video or YouTube video, how you want to say.